Hi everyone, this is April Kaysen with GS1. Today we are trying to provide visibility with the Auto ID Labs. If you haven't joined any of our other webinars to date, we're excited that we will be having Hao Min and Junyu Wang. They will be sharing from Fudan University some of the exciting work that they're working on, but first I want to go over just a few ground rules and then give you some more information about GS1 Innovation Network. For those of you that aren't familiar, I'm April Kaysen. I'm the manager of the GS1 Innovation Network. We also have Adam Radziszewski here with us. He is the Senior Director of Innovation. So I'm going to go ahead and go to the next slide for all of you that are on the call. Give me just 1 second. Okay, as you can see, this is just one of our main slides that we try to share the message of what we're trying to do. The GS1 Innovation Network, what we're really trying to do is provide more efficient problem identification and solving. In innovation, we also need to connect and collaborate with all types of organizations in different industries, as well as develop and increase our innovative culture. So anybody that's worked in innovation before, I'm sure you all are aware that it takes a village with innovation. So we're excited to have you on the phone. And if you have any questions throughout this presentation, you can either raise your hand and we can unmute you, or you can put the question in the question feature and functionality and we can have you ask your question. So I'm going to go on to the next slide really quickly. This is just an overview of the GS1 InZone. It's a collaborative platform that we have opened. It's gs1.brightidea.com. And as you can see, there's just a few things you'll find on the main screen. If anyone has specific questions about this or hasn't logged in, please feel free to log in today and then get back with me with any questions that you have. But if you haven't joined, there's no time like now, so go ahead and register today and start collaborating with us. And just so you can see the innovation team, this is myself on the right, and then there's Adam on the left. If you guys have any questions after, we'll go ahead and get these slides out to everyone so you can ask those questions at that time. Also, here's a slide on Fudan University. We've got Hao Min and Junyu Wang. Hao is a research director at Fudan University. I won't go through all of this information, but both of these are very knowledgeable gentlemen at Fudan University, and we're very excited to have them on the call today. So as you can see, they both received their PhD degrees, and both of them have multiple published papers and patents pending, and as well as granted patents. So again, we're very excited to have them on the call. And Junyu and Hao, I'm going to go ahead and turn it over to you, and you guys can start sharing your screen. Okay. I'll let you know once I can see it, Junyu.
Okay. Yeah, I'm sharing my screen to you.
Okay.
And can you see that?
Not yet.
Okay.
There we go.
So you got it?
Yep.
Okay. Hello, hi. Welcome to this webinar. And my name is Hao Min. I'm the research director of Fudan University. And here with me is Professor Junyu Wang, and he's the associate director of Fudan University. And today I will introduce you some of our research project and the research results doing at Fudan University. Basically, I'll include four contents of this. And the first, I have the introduction of Fudan University. And the second one is we have a prototype for the active tag, which is compatible with Gen2 protocol, which can read about 100 meters on the read range. And the third topic is we developed an implantable glucose sensor tag, which uses RFID technology. And the fourth is a food tracking and the tracing system in China, which we worked on in the last few years. So the first three I will give the presentation, and the fourth one about food traceability will be presented by Professor Junyu. Okay. First, I have a very brief introduction of Fudan University. And Fudan University is founded and 1905, which is more than 100 years old. And we have about 14,000 undergraduate students and 14,000 about graduate students. We also have students from over the sea, about 3,000. So totally, we have more than 30,000 students. And the Auto-ID lab at Fudan University, basically, our expertise is in chip design. So we joined the Auto-ID Center in 2002, and our major research institutes include RFID chip development, which includes tag and the reader, and RFID and the Internet of Things, standard education, IoT application, and all these RFID-related researches. And what we do is basically we contribute a lot to the adoption of RFID technology in China. For example, about 10 years ago, we helped the Chinese government to set up the RFID frequency standard for China, so that these radio regulations in China basically is based on our research and our co-work with China's State Radio Regulation Committee. So, and we also developed the first Gen 2 tag and the Gen 2 reader chip in China, and some of that is right now used in industry in China right now. Okay, so you see our basic major interests and major research work is in chip design area. The another one, the research is in basically is in the application of RFID technology in China. So in the last few years, we joined a big research project and sponsored by the Ministry of Science and Technology of China, which is we set up the track and tracing system for the food in China. Actually, the system is used in China, still is using right now, and we also have a plan to expand that system to more foods and to a larger system. So this basically is our research, and our team include, I'm the research director for the Research University, my name is Hao Mian, and associate director Jingyu Yana, and we also have some research scientists and literature, and currently we have about 7 PhD students and 12 master students, and also some bachelor students work with us. So I move to the next topic, which is a active tag, which is compatible with Gen 2 protocol. Okay. So right now we know that EPC Gen 2 protocol is used very widely in around the world, which in supply chain management, and in China was used in anti-counterfeiting and many other applications. So you will see that the Gen 2 we call is a passive RFID, which means we use backscattering to get the information from the tag. So this is you have a typical read range about 10 plus meters, which is the maximum we can get right now is around less than 20 meters. Basically, we see some report which use special antenna and others, and we get about maximum can get about 20 meters. Normally, we can reach about 10 meters of read range. The reason for that is the tag do not have and the tag do not have a battery to supply the amplifier of the input signal. So this we call the passive tag. And in our research, we first is motivated by a company in the United States. Basically, it's a construction company. It explored some technology to read the tag in about 100-meter range. Why they need that is because they are managing the ASIC in the construction field. So in the construction field, they have these large machines or some other tools, which is pretty large, and they put on the construction field. And they hope that when they deal this read, they can just drive a car and drive the car across the road, and then can read whether these machines and these are on their side. So they estimate the read range is about 100 meters. Right now, what they use a active tag which is operated at about 2.4 gig or 900 meg, which is the active tag. But the protocol normally they do not use this Gen 2. Gen 2 protocol, they use some these active tag protocol. For example, it's like there's a standard group, and which is focusing in the active tag standard. And for this kind of application, they also need they also have some small tags. They use small tools which they use the Gen 2. Excuse me, and I see someone is talking, but I cannot hear.
It sounded like it was just a glitch. We can hear you now. Go ahead.
Okay, so in this in this application, so they have two different tags. One tag is a Gen 2 passive tag, which is used for small tools and for short read range, about like 10 meters or a few meters. They also need a long read distance tag, which they need about 100 meters. But right now they use two different protocols, so that means in the software system and in all the readers they need two different protocols. Which means they have two different systems to get that. So in this application, we try to see whether it is possible that we can use the same tool, we use the same system, which can read both the short distance tag and also the long distance tag. So this is the basic scenario we want to just develop the technology to implement this for this application. Okay. So for this kind of active tag, basically is the use this embed like a Zigbee and beacon, all these kind of technology. So the drawback of all this is basically you have to use two different systems. So why this is the problem is whether we can use a Gen 2 protocol to enlarge the read distance. So what we try to, if we have a battery, then whether it's possible that we put a battery on the tag so that it can amplify the input of the radio and amplify that and send it back. We just see whether this is possible. If we can do this, and we put a battery on that, and then we can transmit this signal back, so that whether we can get this read range get enlarged to about 100 meters. But the answer is no. Actually, there is a standard in the ISO 18000, which is for they call the battery assisted tag. So what they use is basically they still use a backscattering technology and to try to get the signal back. But the issue is if you use this battery assistant tag, we call the BAT protocol, you need a special reader, because the backscattered protocol is not the same as a normal Gen 2. So if you use this, you still need two different readers. So what we try to see whether it is possible that we try to use the same Gen 2 protocol, and we do not need to change the reader, and it can read the tag by 100 meters. So we analyze the bottleneck of this Gen 2 protocol, we find the problem is when if we can basically we can amplify the input signal of the tag, and the amplifier try to get it back. But the problem is when we send the signal back, the send back signal will jam with the input signal. So the whole frequency will be just gets destroyed. So we try to develop a technology which we use a special technology to recover the carrier sent from the reader, basically recover the frequency and the phase of the signal sent from the reader to the tag. And then after recovered, we just fix it. And we let this signal generator stay at this frequency. And then we generate the frequency and send it back to the reader. So by doing this technology, you can increase the sensitivity because we can add a amplifier to amplify the input signal. And we also increase the tag output power because the output signal is recovered from the input. But even when the input is not there, we still keep the frequency of the output power. So then, by doing this, from the reader point of view, it receives the signal is just from a passive tag. Actually, the signal it received from reader is exactly the same as the signal from the passive tag. So we call this technology called carrier recovery circuitry to recover the circuits. Okay. So after we develop this technology, we try to solve all these technical problems for the signal recovery and all these kind of things. So we developed a prototype which to verify whether this technology can be functional or not. So you can see from this picture, you can see that we use a off-the-shelf component to develop this product. To verify whether this can be work or not. You can see from the picture we use 4 printed circuit board which have these standard components there, and we constructed this and then try to get this tag prototype ready, and we try to verify whether this can be work or not. So we use a standard impinge reader, and which you can see in this picture. This is a standard impinge reader, and then we use our prototype tag to see whether it can work or not. So we test it in our lab, and we just use a attenuator to simulate the read distance. So we can see that even we degrade the signal by 91 dB, we can still get this tags that we read. So you can see from our measurement, you can see that actually we got the normal reader sensitivity is pretty normal, and we got the maximum read range around equivalent to 150 meters. After we did that in lab, we tried it in our campus, in our school campus. You can see in the picture that we just put this tag on the road, and we put a tag with the tag, the prototype tag on a shelf, on a table, and we put the reader, and we measure the read distance. We got about 105 meters of read. So, okay. So then you can see this basically is the prototype, and we verify the technology is okay, it is working. But right now you can see that the prototype is just a assembly of this PC board. So it's not a real tag. Recently we are trying to see whether this kind of tag have the industry value, which if we got a industry application and they are willing to sponsor for develop a chip for that, then we will try to get the chip ready. If we can get the chip ready, after the chip and put a battery on that, and then we can reach a real tag which can be read about 100 meters. So this is basically our research in this. So I will conclude this section of this long read range tag. So is there any questions? Okay.
Okay. Guys, it looks like there's one question. Can you provide typical applications of this technology?
Okay, so the typical application of this technology, I think, is basically you need a long read range, or in some space which the signal is degraded very seriously. So we see this technology if you need to read this tag in in a construction field or in a seaport to manage and to read the container, or on a road you need to read the long distance from a road to identify a vehicle which is moving pretty fast. So this we think this is the application, because the first requirement from for this we got is from a construction company.
We've got one more question. Yako, I'm going to unmute you if you'd like to go ahead and ask your question yourself. You should be unmuted.
Okay. Yeah, I hope you can hear me now then. So
yep.
You were mentioning that provided you found somebody to fund this for you, you would then start looking at developing what I would call a commercially available tag for it. So what kind of timescales would be involved in doing that? Because I'm not familiar with that.
Yeah, if we develop the, I mean, if we got funded, then we can try to develop the chip for that. For develop a chip prototype, probably we need about 1 year to develop the chip.
Okay, thanks.
Okay.
Okay, it looks like that's all the questions currently. If you guys want to continue, or does anyone else have any other questions? No? Again, feel free to raise your hand or ask it in the question functionality, and we can come back to this at the very end if you think of one later. Okay, guys, go ahead.
Okay, then I will go to the next topic. Is implantable glucose sensor tag. Actually, the motivation for this research is we see more and more people, especially in China, they can suffer from the diabetics. So actually, in China, the patient of the diabetics increasing and very fast. And the issue is probably in China, food is not a problem, and the people some people just start to eat too much things and cause the diabetes issues very seriously. And so in China right now, this is a big issue, and also it's in the worldwide, it's a big issue. So right now, these most of the people, what we do to detect the glucose level is we use a needle to punch the finger and test the glucose level in the blood. So these people every day, before meal, they need to test this blood. Then this is sometimes it got problems. For example, it's may be infected, and also it's been very painful. And so we try to see, whether it's possible to implement this glucose sensor into, beneath your skin, so that you do not need to every time do not need to use a needle to punch that to have it. And also the need is for sometimes you need very continuous glucose monitoring for these seriously, diabetic, patients. You need to, monitor that very serious, in continuous time. So all these currently is very difficult to do in the in China right now. So And we try to see whether it's possible we can implement a sensor into the body. And then we use the RFID technology to get this glucose level whenever you need it. So you can see, we try to integrate RFID technology which is basically the passive RFID technology, and to power a glucose sensor, and use that to send the signal back. And we put all this antenna, the sensor, into a very tiny glass or some other material tube. Then this tube is less than 1 millimeter. Diameter is less than 1 millimeter, and the length is about less than 7 millimeters. So we put that, under the skin, so then it can monitor the glucose level continuously. So this is what we try to develop, this kind of technology. Okay, so what we do, we use RFID technology. So we have a RFID reader which transmits this 13.56 megahertz signal, and this signal can penetrate into the skin and then go into the antenna. So the antenna will correct this radio signal and convert that to a power which can be used to power the circuitry inside the tag, just has like an RFID tag. So inside the circuitry, we have a glucose sensor, and we also have a sensor amplifier and detectors, and also this analog to digital converters, which convert these glucose level into digital digits. And then this digital digits is just like RFID technology, and send this ID of the tag, which instead we just send this glucose level back to this reader. So you can see by doing this reader, they can get this glucose level of this sensor. Okay. So we use this RFID protocol to power this tag and get this digits back. So the protocol we use is a protocol called ISO 15963. So this is a commercially available protocol, so that we can use this commercial available reader to generate this power and get this signal back. But we designed this tag chip inside this for this tag. So we got this specification of this tag, which consumes really little power because the antenna is very, very small and consumes little power. And we also need to get very accurate current sensor to sense the glucose level, because the glucose level is kind of proportional to the current get from the sensor. So this is the requirement. So you'll see we got our prototype ready, and you can see this left front is the chip picture of the chip, and the next one is the PC board we use to measure the circuitry. In the right hand, you can see the picture of this integrated sensor, but you can see it's still pretty large because you can see that there's a 1 yuan coin in China. Actually, 1 yuan coin, the size is very similar to $0.25 in US. So you can see the size is pretty still big. At the tag, you can see there's a coil, which basically is a sensor, and you see the size of that is about 1 centimeter, which is 10 times as we expected. But the chip is really developed. The chip is actually not that big. The chip right now is 2 millimeter by 1.2 millimeter. So theoretically, we can get this sensor is about like a 1.5 millimeter in the diameter. We can you can accommodate this chip. But right now, this tag is still big. The reason for that is still the antenna is big because we do not use the special technology to get this antenna, and also the sensor is still big. And but we are working on a very tiny sensor, which the sensor size is about 1 millimeters. So if we get this ready, and then we can shrink the size of this tag to about 2 millimeters by 10 millimeters. So we are still working on that right now. Currently, we got this size is still pretty big. It's not suitable for embedded into a human body. But we did work on to shrink the size of that, and we try to verify whether this is a work or not. So what we do is we put the sensor into a liquid which have a glucose inside to see whether we can get this tag working. So by doing this, actually by this measurement, the picture you can see, we get this sensors. We get this glucose level of the liquid. And we also do a test and use in animal tests. We put this sensor inside this animal body and try to measure these measure the glucose level of this animal. So you can see in this picture is what we do is you can see in the glucose level is getting lower, and then we use injection to inject some glucose into the body of the animal, and you can see this glucose level increase very rapidly. At the top of that, then it's getting to the top, stay for a while, and it's dropped. So this curve is continuously, we monitor the glucose level of this animal. So you can see that this tag is basically working. So you can see by the way, the animal we use is the rat. We work with the medical school of Fudan University to do this kind of test. So eventually we got these things. We proved that this kind of sensor works. And right now we are working with a industry partner. They are working with us to provide smaller sensor and smaller technology. Our next object is to have a sensor which is about 2 millimeters by 10 millimeters to increase all the sensor. Then by doing this, we will continue to do a animal test to verify whether all these functions and all this. But till now, we do not know when we will do a human body test. Okay, and this project actually is sponsored by an industry partner. They sponsor us some fundings to develop this chip and develop this prototype sensor. Okay, I think that's the presentation for this glucose sensor. So, is there any questions?
If anyone has any questions at this point, you can raise your hand, and I can unmute you to ask those questions, or you can ask them in the question functionality. By the way, I think this is really great work. I was watching the slides and listening to you talk about it, and even when you guys told us about this before, I just think this is amazing. It could be such a fantastic thing for the U.S. as well with the diabetic patients that we currently have. Does anyone else have any questions? No? Okay, well, oh, wait, we've got one question. Hold on one second. Let me pull it up. What are the other medical parameters that can be measured using RFID?
Okay, actually for this chip right now, we can measure glucose level and your body temperature. And theoretically, we can measure many medical things. For example, it's like your heartbeat and your blood pressure and all this. So all these can be basically can be measured and used in embedded sensor. So we are also looking to see whether it's possible we have integrate more sensors in there for the same chip. Then use the same things. You can get multiple parameters of this.
Okay, great. Are there any other questions? Okay, if you guys want to go ahead and we'll ask at the very end if anyone has any questions, we can follow up on this topic as well.
Okay, so I will hand over to Professor Wang, and he will talk about the food and tracking and traceability system in China.
Hello, everybody. This is Junyu from Fudan University. I will give the last topic about food track and tracing system in China. First, this is the food safety issue in China. Changed from the year 2004 to the year 2011. The red means there's more food safety issue. The blue means there are less food safety issue. You can see in the year 2011 and 12, there are many food safety issues in like Beijing, Shanghai, and Guangdong province. There are different kinds of problems for food safety in China. Actually, food safety is a global issue, not only in China, but since China has such a big population, maybe we have the biggest variety for food safety issue, including the improper selection of seeds, breeders, abuse of fertilizers, pesticides, violation of the food processing, storage, and transportation regulations, and also different kinds of counterfeiting, including complete fake, some adulteration, spoofing, relabeling, and illegally recycling. And also the inefficient recall is also a big problem in China. The authority like Fudan participated in 2 national IoT projects for food safety in China. This is the phase 1 in the year 2011 to 2013. This project is funded by the MOST, the Ministry of Science and Technology. Now the objective is the food safety and quality management, and also develop some core technology and build a scalable platform and standards. This is a reference model of the agricultural Internet of Things. It's divided into 3 layers, including the sensing and identification layer, the network layer, and the application and the service layer. In this project, we used GS1 standards. First is the GS1 key, including the GTIM plus AI plus lot number and the AI plus serial number. By using this GS1 number and the QR code, the consumer, when they scan the QR code using the mobile phone, it will show a directory on his mobile phone, including the producer, the transporter, and the wholesaler, and also the retailer. If the end user click the transportation, for example, it will show more detailed information, including like the source of the food, and also the destination, and the carrier ID, and also the enterprise information, the pedigree, and the map. To be note that if when you click the transportation, actually the information about the transporter is not located in a centralized database. Actually, it will be directed to the database of the transporter. This is a picture about the result and the directory. Just like a website of the company, we are building a website of things based on EPCIS 1.1. And the root namespace is provided by the CNIC. It's a Channel Network Information Center. This organization interpreted all the website with postfix.cn. All the website with .cn were interpreted by this organization, and also they are interpreted the Web of Things for our project. But the Web of Things is different from the normal website of a company because the product will be sold out from the producer to the wholesaler, to the distribution center, and then to the retailer. So that means there will be different database record information with the same product, but they are located in different database. So in our project, we developed directory service, and this directory service will record all different URL of the database with information of the same product. And also we developed the e-pedigree based on the digital signature chain to guarantee the integrity of the information. In our platform, we also developed some apps to prove our, as a proof of concept. We developed our, like my farm, my supply chain, and the product reviews and recall assistance. And also we developed some hardware in our project. I just gave some example here. This is a smart scarecrow, and it has different kind of sensors in the soil and in the air, and it's self-powered by the fan and also by the solar cell. And also